Okay, in this video we're going to be talking about the union or the OR statement. You can see the OR written right there in the center. Okay, so the idea with the union, we take everything. So I don't think I mentioned it on the other video, but an AND statement will always deal with the middle. A union will always, I guess, would be the outsides or the ends when we shade. That's one, and we'll talk about that more when we graph it here. Okay, so this is already broken into the left-hand side and right-hand side, so we don't need to worry about that. And again, just like the and, some of the and statements were and, these two pieces right here do not necessarily are the same, and they can be switched around. This can be over here, that can be over there. So you just have to, it'll just say or statement if it's a union. Okay, so the idea is still the same. All the rules still apply. So I'm going to take 3x plus 5 less than or equal to negative 29. I'm going to subtract 5, subtract 5. That one goes to 0. This one goes to negative 34. Now I have 3x is less than or equal to a negative 34. Divide by 3. So x is less than or equal to a negative 34 divided by 3. So that's one inequality, the left-hand side, so to speak. So x's are to the left. Now over here we've got 3x plus 5 is less than or equal to a negative 16. I will subtract 5 from each side, and I end up getting 3x is less than or equal to a negative 21. Now you notice on this one I'm not dividing by a negative number, so the inequality doesn't switch. So I have x is, have I done something weird here? Let me look at my problem. Oh, this should be greater than or equal to. Let me go back and change that. I could tell my graph wasn't going to come out right because it should be shading on the ends, and I could tell it wasn't going to be shading on the ends. So that's the problem I should have. This is problem number 8 on the worksheet anyway. I just got my inequality messed around. So now x is greater than or equal to, looks like a negative 7. Okay, let's go ahead and graph this. Now remember the and statements graph in the middle, the or statements graph on the ends. That's how you're going to check this. So this should be a negative, looks like a negative 11. So negative 11 and what, 1/3? That's basically what that is. This is closed. So I'm going to color that in, and then I'm going to shade this way. So everything this way shades. Okay. On the other side, x is greater than or equal to. That's also closed, isn't it? Yep, they're both closed. So I'll close it, and then I shade this way. This is to a positive infinity. This is to a negative infinity. Okay? So now, when you use infinity, we do not know where infinity is at. So if I'm going to use interval notation on this, I have to use this one to show infinity. That will always, because I don't know where that number's at. I know it's there, but you can't find it. And then I'd have a negative 34 over 3 for the other boundary point, and then that would be closed. So here we're using the interval notation right here. Now over here, it's still closed, and that one was a negative 7, and then it goes to a positive infinity, and that positive infinity is open as well. So that's how you do an or statement. Or statement shade on the ends. The and statement shades in the center. That's how you check it, is by your graph. And don't do what I did by making a mistake when I wrote down my inequality. I wrote it wrong. But one thing it did tell me is that when I got to the end, this is gonna shade this way, I'd have a double overlap. I can't have that with a union, I can't have it with an OR statement. So I knew it was wrong, so I went back and I looked at my problem and I picked up that mistake right there. Okay, well, thank you for watching and have a good day.